All right, everybody. It's about that time. I hope y'all are having an absolutely amazing Saturday. Hey, Bobby. What's up, dude? All right, let's kick this off. We're commencing. Boop. I didn't help out, E. See this little, like, weird stuff with the green screen right here? I was trying to adjust it to fix it. It didn't like that. Hang on. Let's see. Does that make any difference? No, I just need to adjust the lighting in here. Anyway, what's up, everyone? I hope y'all are having an absolutely satisfactory Saturday. Trying to think of an S adjective. I want to look at something here. So, speaking of Bobby, he had told me about something that I had not seen before because we've talked about adding a retrieval augmented generation system to HackBot. But something that came out about a year ago that I missed was called a GraphRag. And so the idea is using a graph database or some kind of a vector database. Oh, actually, I'll take it back. Typically, retrieval augmented generation uses a vector database, takes in a bunch of text, chops up in little pieces, and then puts that into a database. And then whenever you send a question, it chops up that question, looks at it as a vector, and sees, hey, what's close to it? Can I grab some chunks of text to throw into it? It works fairly well. It's a neat idea. Adds a little bit of processing overhead time. It's not a big deal. However, the idea of a graph system actually seems kind of cool because what do you have whenever you've got a graph? It allows you to like kind of tie pieces of knowledge together. So I was taking a quick peek at it here because a lot of the stuff we do relies on a lot of other things. There's linkages between them, right? Say, for example, we wanted to have a piece of information about the Windows API. Well, that's very graphable, believe it or not. So this might be something we could go through and potentially use as part of the teaching system later on. Let's see. So this is one I just saw. It sounded kind of cool. Someone on Reddit had recommended it from a thread I was reading. Actually wasn't expecting this because the thread was about a year old, but this was actually updated 3 weeks ago. It's called Veritas Graph. So GraphRag seems like a nice complement to a traditional vector DB for semantic search and to help with retrieval. Yeah, and that's what I'm hoping, Bobby. So I just wanted to read through it real fast and get an idea of it so I can let it percolate. I can let it kind of, simmer in the background while I think about it. Because we're a ways off before we start in adding like the retrieval augmented generation to it. Right now we've got a context process that kind of keeps all the context together. But I'm always thinking like, hey, what are we going to do once we get to this point? So I'm kind of planning ahead a little bit. Let's see. One thing I love about this is it's fully on-premise. You can run it with local models. So every generated claim is traced back to its source document. Hang on. I tried to breathe the Jocko. Don't breathe the Jocko. Just drink the Jocko. Let's see. I like the idea of this. Let me take a look at this demo real fast here. A MAV file. Ew. They couldn't have recorded this any better way. They had to do cell phone on screen. Okay, I'm not watching that. I'll mess with it later. I want to take a look at it, but it sounds kind of cool. Only thing I'm worried about is will it add complexity to when people want to add a knowledge base to a specialty agent, right? Okay, so it looks like they're using Gradio to do like the setup for it. It looks really cool. I'm going to play with it later. However, right now, I've already got HackBot spun up and doing its initial test run. So we can kind of see where it was failing at. Okay, so we hit a rate limit error, which is expected. And it's because the browser agent... See, we call the browser agent, and it's just using way too much information in here. Oof. I'm out based on that janky MAV file. Dude, I haven't seen anybody use an MOV file in a while. They must have recorded it on an iPhone. All right. So I already did the initial test run. I actually was on the ball this evening getting the lab all set up. So let's see what we did here. This one let me just skip down to the exploitation agent. All right, so for exploit, first thing we do is we tell the exploit agent, hey, figure out how we're going to do this. Actually, it just comes up with the exploit. So the planner, what did we come through for our planning steps? Let's see. So obtain a basic web shell payload, navigate to the target's upload panel, upload the PHP web shell, and access it from the uploads directory. Okay, cool. So when we go to the processor, first thing we do is we can see it. We don't have to think about it very hard because we can see the call. It pulls a copy of the Diceco PHP web shell. Very cool. We get that. Let's see. And then what's the next tool call we make? So the next thing we do is we pass it down to the browser agent and we hit browser navigate. Okay, so browser navigate failed. Then we did a HTTP get. Let me try this again real quick. Hold on. Actually, what did the get do? Did the get response come back with anything? Yeah, the get response came back with some stuff. Let's see. What did the reviser say about this, though? Okay, so it validated it with the HTTP get, which is kind of funny. I wonder why the browser navigate failed, though. I wonder what caused that to happen. Anyway, but that's fine, because once it does that, what's the next step we're going through? Let's see. So the next step here, it is navigate to the upload panel. Wait, wasn't that what this one was just doing? Oh, I know what happened here. This is great. So check this. This is awesome. This is actually not what I expected, but it's showing the error correction working. So what happened? We called the browser agent. The browser agent tries to navigate. It gets a timeout. Okay. So then when we come to the reviser, what does the reviser say? The reviser is going to say, hey, by the way, this failed. Check if the target's accessible by navigating to the base address. So it does that. It doesn't go to panel. It just goes to the base IP address. And that works. So then it's like, okay, cool. So if we look at this, hold on, where's our reviser? There's the reviser. So if we look at the step update, let's come back. Because what should have happened here is we're going to see a new exploit step get inserted into the list here. So here's our steps. Let's see. So step 1, obtain the web shell. Step 2, navigate to the upload form. Step 0 is that. And then the next step after that was upload it, right? So then when it tries to come over here to do the HTTP get, if we come over here to the tool node, right, let me collapse these down again and drill back into it. Right here. There we go. So now look, step 0, still obtain a web shell. But now step 1, instead of navigating to the upload panel, is check if the targets can be navigated to, right? So that works out perfect because that means the reviser actually came in and said, hey, here's what I want you to do. And it should be a new step. So if this new step is set to true, what does it do? It inserts it prior to the step that failed as like a precondition, and then it continues on. Nice. Was not expecting to see that off the bat, but I'm glad to see it's still working. All right, so after that works, then we hit the browser navigate. Let's see how our navigation went. Looks like the navigation was good. Excellent. So then from the reviser, what do we see? Reviser says it was validated. Excellent. And then what was our next one after that? It is... Hold on, we got a lot of context in here. What was our task? Upload the PHP web shell. Okay, cool. So we do a browser upload. And chances are it should say, hey, this is going to fail because PHP is not permitted. Right there. You can just barely see it right over my shoulder right there. Excellent. All right, so the reviser comes through. What does reviser say? Should say something like rename this. There we go. Yeah, rename the PHP web shell to a different extension like PHTML or PHP5. Nice. So then it calls the file rename. Let's say what we rename it to. Renames it to .phtml. And then it comes through and does the upload. The upload is successful. Ooh, Daddy likes. Daddy is happy. Excellent. So we're able to put the .phtml in there. So then let's make sure the reviser actually accepted it. It validated. Wonderful, wonderful. All right, so then what was the next task here? So access the uploaded web shell via the uploads directory. Awesome. And this is where we finally said, hey, by the way, you're sending too much data too fast. So understandable. It's probably because here, if we look at this call here, our input is a lot of stuff. Look at all this we're sending to it. So it's a kind of a chunky call because we have the entire context in here. So what I'm thinking about doing is when we rebuild the browser agent, what we'll do is we'll have steps that occur in here. And the steps will say, what was the step taken? What was the output? What was the step taken? What was the output? We're just going to make a pairing of them in here. Boom, 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 boom. Just write down the list. And rather than doing it as two sets of lists like I tip to do, I think what we'll do is we'll do it as a tuple because everything's going to have two pieces to it. Step, the output. Step, the output. We can just do it just like that. So here's where it crashed out on us. Let's see. But actually, I want to go try something real quick. Let's go pull up the testing box. And hold on, I got to get the IP address for the server. There it is. Boop. Let me throw this in here. Let's see if we see our uploads directory. We do. We see webshell.phtml. If we click on it, do we get anything? Hey, Cypher, what's up, brother? Happy Saturday. All right, I believe this was CMD. I don't know if this is actually going to work. Let's see. Who am I? No way. No way. I didn't think PHTMLs would work, but check that out. I thought you had to do the... Okay, I'm not going to tell you. That's awesome. And look at this. So we don't have anything else happening in here. Oh, this is fantastic. This is amazing. Let me try something else real quick. I want to try one more thing. Let's see. /etc. Okay, so for some reason it only gets like the... What do you mean command not found? What? I'm not looking this gift horse in the mouth, Cypher. No, 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 no. I think that's great. I kind of saw it last time. However, I want to see if I can try something else here. Let me see. Let's see if I can get something else to run here. So if we do an LSLA, we see... We should just see like one file come back. And in fact, that's kind of extraneous because if we come to the uploads directory, right? For some reason, this connection is very slow. I might need to go restart the VPN because the VPN's actually probably been on for a long time. So let's kill it. And I'm going to restart the VPN. Let's see, reload. Let's see if this works here. Come on, you can do it. But that's awesome that that .phtml worked. Because now it just means if we optimize the browser agent, we should be good. We should be stout. Okay, hold on. Did the VPN... It looks like the VPN came up. Ah. Oh, no. Damn it, hit the wrong button. Let me see. What's going on here? Why is Ton Zero not showing up? Hey, Biwoo. Biwoo, what's up, man? Thanks for coming online. Welcome in. All right, did I kill the VPN on accident? Let me see. It looks like the VPN connected correctly. TLS error. You're killing me, Smalls. Hang on. Okay, now are we on the VPN? There we go. All right, now let's go try this again. Refresh. So the only thing showing up in here, just from, and Apache has no reason to lie to us, is the PHTML web shell. Perfect. That's great. We can do that. Excellent. I know, I wasn't expecting that, Bobby. I wasn't expecting the PHTML extension to work. Now let me see what was HackBot trying to do now? So after it validated everything, let me double check this. So it validated the upload PHP. We're good there. And now, if we come back here, we call the browser agent to do what? Access the uploaded thing here. So we call browser navigate. And what do we get from this? It looks like we do get some information out of this. Let's see what we get when we access it directly. So we don't get anything rendered on the screen. However, if we view the page source, there should be something in here. Really? Nothing came back? Okay. We might have to go massage it a bit more because we know it's working, right? If we throw a CMD in here and we tell it, like, you know, again, who am I? Boop. We see that we are trip dev data right there. So we're running in the context of the web server. Perfect. That's awesome. It'd be nice if it returned something in there, like, hey, you know, this is Diceco, whatever. It wouldn't be OPSEC secure, but you know what? Who cares? Because it would still work. This is not meant to be super stealthy red team bot. It's meant to be capture the flag bot. All right. See, we're already getting kind of chunky right here because we have 29 messages just in agent right here. So, all right, let's start re-architecting the browser agent. Let's see. There's our browser. I remember where we did this at. I believe it was down here. Yeah, so down here is where we actually create the React agent, right? So we need to make this an actual agent now. Let me see. How might I do this? Because what I was saying is, what I think we should do, if it's going to let me do stuff, there we go. So let's think about the state table for this. So the state table is going to kind of just look like basically action result tuples. So we'll do this. We'll say it's going to be an action and then the result. And in fact, I think I want to do one more thing. Maybe we'll call this the node. We'll make it a thruple. So what should happen here is the action is, hey, this is the direct action we took. Here's the result. Here's the node. Okay. Let's take a look at something real quick. So let's look at our previous browser agent interaction here. So when we call this, what do we have as far as our background? We have it hit panel, we had an error, and then later it comes in and says, okay, cool, well, we can hit it, so go ahead and upload the web shell. It uploads the web shell, we get the output. And so anytime you see human in here, what it's really doing is that's basically instruction that's been passed from HackBot down to the specialty agent. It's not actually a human interaction. All right. I'm trying to think if this will work. And I'm trying to think how to maybe do this, because what's happening here is, like, this is our tool call, right? We're going to say browse navigate, and then here's the URL. So we want the tool calls, but we also want some kind of output to come back from it. And you don't really see it in here. Let me see if I can show y'all something real quick. Let's see. So from the input, if I come to the input and I come to the raw input, this is all the data it's sending, right? Look at this. This is a lot that it's chunking through there. So all of that is what's getting sent. And there's a ton of it that's just, hey, this is just nonsense overhead that we can cut out of there, right? There's a few pieces that aren't that we might have to actually keep in here. Let me see. I think this was the human message here. Yeah. I wish the iPad was working, damn it, because the iPad is dead right now, and so I could diagram this out. But what we've kind of got happening here let's see. Let me think about this. I'm just typing up some notes here. So on the HB side, what we're getting is we're getting output from all the exploit steps, right? So when this gets prepared by the exploitation agent, let's see, where's exploit agent? Right here. Let me close some of these out. Don't need the output formatter, helpers, context helper. I think we're good there. Don't think we need tasking. There we go. Don't need LangChain. Don't need... I don't think we need PHP here. So what's going to happen here with the exploit agent is when we call our special agent, here we go. So where does that map over to? I'm trying to remember. Let's see, that's our step revisor. Step, I gotta figure out where that maps to. Unfortunately, the only downside to having those static strings returned is there's not a good way to see where this goes. So, where's our special agent tool node? No, we gotta find this down here. Let's see, special agent node, here we go. That's the one. Hey, Iron Man, what's up? Thanks for coming online, dude. Welcome in, and I hope you're having a stupendous Saturday. All right, so when we get ready to call the special agent, what's happening here is we get our agent to the call, we execute it, and that's about it. Okay, so this logic, I stand corrected. It's not happening in the exploit agent. It's actually happening, the context preparation is happening over in the actual browser agent code. So let's see here. So if we're doing an exploit agent, let's see. So here's our result. This is actually what we're calling. We're sending a browser task. The browser task is, we take the step, we build the content. Oh, actually, I did have this. I did need that open because we defined that over here. We had to build exploit task context. And what this should do here, I should put a doc string in this. That's lazy Blaise's fault, which is past Blaise, which is me. Let's see. Let's put a little doc string in here. Let's see. Build the context for an exploit task by task. Concatenating. Shut up, baby. I know it. Hey, Frozen, what's up, man? And Genius Jordan, hey, what's up, dude? Happy Saturday. Did I really spell concatenating wrong? Did I? Yeah, there we go. Let's see. What are we concatenating? I'm trying to remember here. So we get our step outputs, concatenating the output for all steps. There we go. Let's see. For all of the task steps. There we go. Excellent. Is it giving me like a grammar error here? Really, IDE? Sure, why not? What am I using to trace the agents? Right now, out of simplicity, I'm using LangSmith, which because the architecture is written entirely in LangChain and LangGraph, so it integrates perfectly over to LangSmith. And we're using LangGraph Studio for actually kind of like interacting with the agents directly. So I've already done the base run for tonight. So what happens here is we've got a dirty little trick set up in the exploitation agent where we actually will, if this node gets hit, every time a node gets hit, it gets a copy of the book of truth, the state table. So what we'll do is if the state table is populated, we'll save it to disk as a pickle file. If it's not populated, basically if it comes in just blank, right? Then what we'll do is we'll load the pickle into the state table. This way we can just kind of cheat and just run the exploitation agent. And so everything is being managed from the LangGraph Studio right here. And then when we need to go trace it, we'll do it over in LangSmith. Eventually, I'm going to move this into a different solution where we can kind of see it better. Maybe with, gosh, what was that other one called? I think it was called LMFlow. Was that the right one? And I can't believe I'm blanking on the name because actually I told my coworker about LMFlow. Let me see if they got a picture of the interface. I'll remember it then. But yeah, so because eventually I want it to be completely not isolated, but basically self-sufficient. You don't have to rely on this. This is just a way to help with some of the bootstrapping, getting it going, tracing what the agent is doing and whatnot. Let's see. I finished it off real fast. Not sponsored by Jocko yet. Working on it. Working on it. We'll switch over to T now. All right. So the long story short is the browser agent context is getting chunkified. We need to de-chunk it. We got to put it on a diet. So that's what we're going to do tonight. Let's see. Builds the context for an exploit task by concatenating the output of all the task steps together. Excellent. All right. Let's see. Let's come back over to browser. So here in browser is where we're doing this. So we're going to need So what we need is we need a basic React agent to happen in here. The downside is the create React agent doesn't do a fantabulous job in here. Because that's what we're using. We're using the built-in create React agent from LangGraph. There's some knobs and switches you can turn on this. You can have you could modify the state of it. I think it's just going to be a better situation if we go bootstrap our own in here. So let me think about how I want to do this. I'm almost thinking about, damn, I wish the iPad was working because I could draw this out. But what I'm kind of thinking is we'll basically make our own create React agent function, but instead of it always using the message table or using anything like that, what we could do is we could pass it like a function. And the function actually says, here's how you handle like creating the state and whatnot, because this is not too dissimilar to kind of like what we do. Let me double check something real quick. So the first time we run the browser agent is up here where we do the navigate. Here's the kicker to this, right? Let me do the default input right here. So this actually isn't even using any kind of special prompting or anything. It's literally saying, hey, navigate to the target upload form. Here's our previous exploit step data. Boom. We just send that to it. And in fact, probably what we should do is we should probably actually modify, see this? Because even this has some extra stuff in it that we can try to use to reduce this. All this extra formatting in here, really it's just the content of what we need. So let's make that kind of update to that for the context helper here. So rather than grabbing the output, I gotta remember what the structure of that state table is. Or really that, it's just a typed dictionary, really. Let's see, so this is going to be an exploit task, actually an exploit step. So there's the output. Yeah, there we go. So this is all coming back. So here's our context of what we do is we say, hey, here was the task, right? So the task was obtain basic PHP web shell. Here's the output to this. Now, this right here is basically the reason why I did it this way is because what we're doing is we were taking the entire thing, because this could be multiple outputs, right? It's a list. If we look over here, the output is a list. The number of tools could be a list in here. So I think instead what we want to do is we just want to get the output from that. So what we need to do is, let's make a quick update to this. So let's do I output length. What is going on here? There we go. And what we're going to do is we're just going to get the length of I underscore output. I don't want to do that. Actually, what I'm thinking about doing is let's move this line up here. Let's do this a wee bit differently. So what we're going to do is we're going to drop this up here, and we're going to copy this line and bring it down here. Because what we're going to do is we're going to just iterate over this. Let's take that out. So we want the task, and then we want whatever the output is to this. So what we'll have is, here's our task, and then we'll have basically like a markdown type situation where we say, okay, here was our output from this. And the white spacing really is just for human readability. The AIs, whenever they're processing it, they usually, during the tokenization process, they strip out a bunch of the white space, some of the punctuation, things like that. It just depends on whatever tokenizer you're using. So let's take this part out. So what we're going to say is this is the task. Yeah, just like that. Let's do this. So we're going to say here was our task. So we're going to append that to it. In fact, we could even just do this up here. No, wait, we need the task to be extracted because it hasn't been extracted yet. So that's fine. We'll leave that right there. And then we're going to get our output. And then what we're going to do is, I think it's for, we'll say J in, I think it's range. Range for the length of I output. Except I screwed that up. There we go. I think that should give us everything we need in here, because then what we're going to do is we're going to take this part out. Yes. Actually, no, we need part of this in here, because what we're going to do is let's take this part. Yeah, we'll do it like that. So it's going to be kind of markdown-ish looking, and we just want one line return at this. And then what we can do is, actually, before we even do that, we need to do something else. Now, what are you complaining about? Oh, I'm missing a closing parentheses. That's what. All right. So now as we iterate over these, what we'll do is we're going to, rather than getting this, we're going to get this value, and then we're going to extract just the content here. This might actually introduce some issues, but it's fine. So what we're going to do is we're going to call this JStep. And then this is what's actually going to get appended to the context here. Boop, just like that. And let's see if it hot loads in properly. All right, looks like it did. Sweet. So now, what should happen? Now this is making an assumption. Oh, I'm an idiot. Ooh, this actually needs to be indexed on J right there. That's the whole reason why we had this for loop in here. So we loop over it. This is going to be basically, so if the range is 0, right, we should just have that. Is that going to work? You see something. Range 0 to 0. Let me see. For I in range 0. Let me try this real quick. Print. This should probably be +1 in here, if I remember correctly. Come on. Just run. There we go. Yep, I'm glad I double-checked that, because I forget exactly how the range works here. So, from that example, where was it? Yep. So we want to increase that by 1. So we'll do the length of this +1. There we go. So we're going to extract just the contents, and we're going to spit the contents in there. Let's go double-check that that actually works. Let's come back over here. So now what we can do is we can actually just run the exploit graph directly. We don't have to run the entire Stinger workflow. All right, so we're hitting the planner. We're doing good. I think one of the next steps, after I get the exploitation agent... Ooh, the exploit step processor ran into an error? That's not good. It looks like it didn't like the new code we just added. String indices must be integers, not strings. What? Hold on, what's it saying here? The string indices must be integers, not string. Let me double check something real quick. Let's go back to one of our previous runs real fast here. Now, I guess we'll just have to use today's large run. All right, let's get down to the exploitation agent, because I want to check something real quick. Before we get down to where it crashed on us, if we start here, and let's take a look at the tasking. So let's go down to task index 5, and then our steps. So what's our output look like? It looks like just a piece of data right here. And for this one, we specified this. We said tools a list of strings. Yeah. Oh. That's why. See that? So it's actually storing this as a string when it does that. That's not going to be good. So we can't pull out that content because, as far as it's concerned, this is a string in here. Let's see. Well, one thing we can do is we can parse a string as a dictionary. I got to remember how to do that. Let me see. Parse string to dictionary. Let's see, we can use JSON loads to do that. We could also use eval into here. Maybe eval's what we're gonna do. Let's see. Eval function can also be used to convert a string dictionary into a dictionary. However, it's not recommended for untrusted input due to security risks. Okay, we probably don't do that. All right, where was this other one here? JSON loads. I think this would be the best one. Converts a JSON formatted string into a Python dictionary. However, JSON strings must be double quoted, which I believe they are. If we look at the output in here, yeah, everything's double quoted. So this should actually work just fine. So let's do that. Hold on, what was that damn function? JSON loads, that's it. Don't want to necessarily use eval on this. What's this other one? AST literal eval function from the AST module is the safest and most efficient way to convert a string dictionary to a dictionary. Okay, we could do this. Question is, can I import AST? Let me see. Do I have to add that? Let's see. Import AST. Oh, cool. I guess it's part of the Python kind of standard package. Nice. So what we'll do here instead is we're going to do AST. What was it? It is literal eval. Okay, we need to store that as the... Okay, so it's a type dictionary and this is it. So yeah, we can actually just wrap this right here. Ooh, that should work, I think. Wait, this is weird. Expected a type string, got a type dictionary instead. Oh, this is bunk. Let me see. So what should be happening here is we should have the tool name and then the output for this, which comes up as a dictionary. It doesn't like this because it thinks this is not going to be correct. Damn it. I wish I had the debugger set up because then I could go pop it and I could say, hey, what is going on with this? Hey, Joe Father, what's up, man? Sorry, I am digging deep into this. I missed your message there. So what we're working on is a little AI hacking bot to play capture the flag games. So stuff like Try Hack Me or Hack the Box, anything like that. And it's actually working pretty well. So here's the overall view of things. So Stinger is kind of like the supervisor, and then we've got a recon, enumeration, and we're currently working on the exploitation agent right here. The exploitation agent is the first one to integrate a really cool function that I don't think, did I put this in recon yet? I don't think so. I didn't. The exploitation agent has a cool function that we just added a couple of weeks ago where it can call what's called a special agent. So rather than trying to cram everything into this agent, we can make modules we can go pop in, they'll load at runtime, and when they do, the language model will have access to them and can say, okay, I know just the agent to handle that task rather than me trying to do it myself, and we can send it to the specialty agent. So this first special agent we've built is one that interacts with an MCP Playwright server. It's working great, however, it's not very well optimized, and we keep hitting an issue where Anthropic comes up and says you're basically getting rate limited and it's crashing the program because it's tossing an error. So what we instead need to do is we're going through and we're optimizing that browser agent as it sits right now. Part of that is cleaning up how the context gets, let's say, attributed or built up in here. So I'm thinking maybe I'm making this too complicated. Because what I wanted to do is here, we get this dictionary, right? But unfortunately, it looks like it thinks it's a string, even though it's a dictionary. Oh, that's gonna not go so well. Okay, I'm gonna back out the changes that I've made here. We're gonna leave this part in its unoptimized format. We'll fix it later. So let's back you all out. Let's see. Should be coming back to right about there. All right, so this should be where it needs to sit for the time being. And in fact, I'm gonna go commit just this part of the code. Where's the context helper? Let's see. Context helper. Commit. I'm not going to push it yet because I have like 3 months of unstaged pushes that I need to do, code commits, because we go on this really long sidetrack of building the browser agent. That's working, but then also building the browser agent included the functionality to load the special agents. So it'll be really, really cool once we can get that going, because then somebody can come build a specialty agent to handle whatever task their heart desires, drop it in there. As long as it's formatted correctly, it gets brought in and is available at execution time. So very cool stuff. However, that caused this huge backlog of commits to the GitHub repo. And so I'm trying to get the exploitation agent to where it can complete its task, which is it needs to get command execution on the system to be able to just execute one command at a time. That's it. After that, it would be handed off to the post-exploitation agent to upgrade it to a C2 interaction. So and we're going to do that through Mythic C2. It's going... Oh, it's so close. I did a test run just before the stream started, and it got all the way down to... It uploaded the web shell. Let me see. Let me see the actual output here. What did it do when it navigated? So it navigated to uploads. It probably saw that the upload was there. However, that's where it kind of busted up on us. So what we should see is the next thing it should do is try to go access the page from uploads and then attempt to run a command to verify that it was working. At that point, it would say, okay, I have the initial access payload and we're going to pass it off to post-exploitation. There is no post-exploitation yet, but once it can do that kind of consistently, I think we're going to be golden in here. It's going to be good. All right, let's see. All right, we're going to leave the context helper alone for right now. Let's go back over to agents. I think it's all good here. Wait, did I already do this? What was line 59? Oh, I had a to-do in here, because right now we only have one exploit task, so it's not such a big deal. However, we need to go through and clean that up. Actually, did I already do that? I don't know. I don't want to get sidetracked. I should leave better descriptions for myself, because like what I did this so many weeks ago. I don't remember what this was. Fix minor exploit task changes above. Was it the one to get the current exploit task? Was that it? I think so. Hold on. I do want to fix that real fast, because it's going to bug me if I don't. And of course, I think I closed that file, which was the tasking utility. Where's tasking? Let's get our exploit step. Get current exploit task. Yeah, that was the one. I think I already imported that. Let me try something here real quick. Oh, what just happened? Scrolled up to like something weird. Let me see if I can fix this one real quick. let's see. So task is, we're indexing this on the current task. That's our task output. Which actually, I think this should be, I think this is the one actually I need to replace right here. Task should be get current exploit task. And for this, we need to pass in the state to this. Which I think this tells us what the exploit task is. Yeah, I am going to fix this up real quick, because the browser agent needs some leaven since we've adjusted it a bit. So this shouldn't be our task, this would be our exploit task. Wait, is that how I did that? What's going on here? Oh, this returns an index. That's right. Let's go adjust that real quick then. So this would be the output from the current task. That's what it was. Take this back. Let's drop this out. So rather than this being 0 right here, it's actually going to do get current exploit task from the output, because damn it, wish the iPad was working. So what happens here is these tasks, they store the exploit task in the output. So the exploit task is kind of like a subset of a task, and then each task can have basically be an exploit task, and then from there, hold on, let me see if I can show you real quick. Let's see. Where is Stinger state? So here's our task, right? This would be a list of our tasks. And then if we look at the task, what we have is the output can either be a dictionary. And so this is like a normal task. If it's a normal task, it's going to have a dictionary for the output to keep track of what happened. However, if this is happening for an exploit task, then the output type becomes an exploit task. And in the exploit task, like I said, it's kind of weird because it's stored in the output. But then the exploit task here has all these different steps to it. So then we have exploit steps to accomplish that. The idea behind this was something called what I called speculative tasking. And that is, we don't know if an exploit is actually going to work until we attempt it, right? So we might look at a system and think, okay, I think I've got 2 or 3 different exploits that might work. Let's go ahead and buff those up. We set them up, we develop an exploit task, we run through the steps. If we find a blocker, we probably assume that, okay, it's not working. Let's go to the next task. We run through the steps and so on and so forth. So it gets nested real deep in there. I will document all of this soon. Hey Monkey, what's up, man? Output can be a class. Yeah, exactly. So let's say, for example, here. So for our normal task, the output is a dictionary. That's a class, right? It's a type. So we can take all the output from a tool call and we just drop it in here. Same thing for the exploit task. So we're keeping a pretty good constraint on the context, except for when it comes to our browser agent. Our browser agent is doing stuff just completely off the wall in here. So I think what I want to do is, let's see, where are we actually making use of this output format? Let's see, go to implementations. Where is this? Declarations or usage, let me see. So we're using this at line 81. Oh, okay. This is where we're actually formatting all that information. Got it. This output formatter might go away here in just a second. What we're going to do is we're going to actually define a new class here that's going to be our state table in the states. So let's do that real quick. I can't believe I didn't actually start that already. Guess not. Did I really not start that? Weird. Oh, yes, I take that back. I know where this happened because it's not in agents. Let me scoot this back over here. It's because it should be over here in browser. what we should have is we should have a class starter for this. Yes. Let's call this our actions. And this is not going to be a list of tool messages. This is going to be a list of tuples, which is going to be should be like a string in a string, like that. I think that's kind of what we want. So the string would be the first one here. Let's put a note here. So this should be our let me see what I want this to be. This would be like our action and then the output. The other question is, should we track the task in here as well? Like, hey, this is what task this is associated to. So our task, which would be a list of strings in here. I think that might work as well, because what we could do is we can use the same old trick we've done, which is this will be a list, this will be a list, and then they'll index the same way. Let's see, indexes to actions. We can do indexes to task. Yeah, I think let's do that. Did I spell indexes? I sure did. There we go. I think this will work. So what we have here is now we're going to have a custom state table for this agent. So what do we get passed to this agent? Let me double check something real quick. Because what I'm thinking is we kind of massage this, and then what we do is we return this state from it. Actually, I take that back. No, because the way this class is instantiated, we have our own state in here. So this should probably actually move down to the persistent browser here. This is one of the few pieces of this entire code base that was AI written. And I used, I believe it was Claude, to help write this, because I wasn't quite sure how to get it going. Unfortunately, I think I realized a little too late that the solution was much simpler than I thought, but at the same time, it was already working, and I had burned, I want to say 3 months trying to make the browser agent work, and I didn't want to keep burning a ton of time on it, so I just rolled with it, and now I'm kind of regretting that decision. So you see where it says, like, it's got these, like, faux state variables? Where was this defined at? So you get or create the state of the session. We actually could kind of use this here. I don't know how to define these though. I don't remember what type this is. Because the Docker socket, actually that returns a Docker client. Let's see. I'd have to go through and I have to type all these out. So here's our session context, here's our message history. I don't know if this is actually even being used. Let's go find out real quick. Let's see. I regret this. That's where this is coming from. From the execute task here. Let me come back over to here real quick. Where do we actually call the browser? Let's see. Where did I put that? Let's see. Here's our browser wrapper. So in agents, what we expose is we actually expose this browser agent graph, which is this guy right here. All right, I think I need to unflustercluck the browser here. So let me double check what exactly we're doing when this comes up. And I'm going to take notes on it, and I apologize, you're not going to be able to see it. I don't know why all of a sudden the iPad driver is just not working in here. Let's see, so our browser, our persistent browser here, we've got a class defined for this. And we pass it a session ID. So init is going to take in a session ID. And that's deterministic from basically the IP address of the system. So we go to the browser node, which is our browser wrapper. We come down to the browser wrapper. Let's see. So from the browser wrapper, we do a little bit of massaging here first. So first thing we do is we initialize a couple of these as nuns, and then we actually set them up. Wait, are we actually not using this agent here? It is. We check the agent name. If it's in persistence tools, which is our state table, that's where we're storing the object for the browser. And then we check for the session name. Let's see. We check if that browser option actually has the session name, which is going to be browser and the target IP address. And the target IP address also comes from the state table. So if we look down here in the stinger state, we have our... Wait, where was our target IP? Oh, there we go. Yeah, it gets the target IP from the current task. There we go. It's right there next to it. All right, so we check to see if it's already, if we already have a persistent browser for it. That's fine. Let me check something real quick here. Where's our MP stuff? Because really, the entire thing was the way I had understood it, and I'm not very good with async in Python. It's on my to-do list, trust me. I've got a ton of stuff going on. I'm getting ready to release a very chunky blog post that's called a gentle crash course to large language models. And it's a pretty good-sized post. So it'll be out in a couple of weeks. I just finished the draft on Friday and have gotten some good feedback from a bunch of my buddies. And I'm getting that in the QA pipeline. So it should be coming out hopefully pretty soon. Like I said, probably... When is that? Maybe a week, like in 2 weeks from now. So it has time to get QA'd and prepped. But that's kept me up pretty late. And then I've got one other thing that I'm trying to get ready as like a Christmas Advent type surprise for everyone. And it's going to be a vulnerable web app that I was going to put out as like a, you know, like a Christmas CTF. So I'm trying to work on that too. So I haven't had a lot of time to bone up on all of my Python. I've been dabbling with hosting my own local LLM, so that'll be an interesting read. It doesn't cover anything like that. I do mention Ollama, and there's a could be a code example in there to play with. What was that? It was a very simple code example of like running a local agent and just to tinker with it. And of course, it's written in LangGraph because that's what I know the best. But getting started with the Ollama, it's pretty simple, and I like it a lot. I kind of lucked out that the graphics card I've got in this system has 12 gigs of memory, so I can run a couple different language models. But I have an old hash cracking server that sits right behind me over here. And it's got two NVIDIA 1080 Ti's. So each of those had 11 gigs in them. So I've got 22 gigs of VRAM that I can load up a model into. It's not amazingly fast. It's still pretty fast though, because they're not very big models, but it works out pretty well for hosting stuff locally. I do miss my old server I used to have access to at my last job, because it had 8 NVIDIA Titan V cards, and those cards all together had 200, I think, gigs of VRAM. So I could load some pretty chunky models, or I could load lots of different kinds of models. So I miss having access to that. Let's see. So here's actually where we start the Docker container. We get this going. We start our MCP client. We define it right here. Oh, that's message history. Look at the wrong thing. Where's our session context in here? This is then for closing the browser, though. Where's our first mention of this, though? So here's our state context whenever we're in the... let's see. So this is our get state session, where it'll make one if we don't have one. We set this to session browser. Now, where's our state client actually come in? This is it right here. Let me look at something real quick. Here's our multi-server MCP client. What is this going to return? Kind of returns a none in here, which that's weird. Hold on. Why does it say return type is none? That's so odd. I'm trying to see if it will trace this down right here. Let me do something real quick. I'm going to just do something real fast here. So here's X. I'm just spitballing something real quick. And then what is this session supposed to be called here? Well, yeah, okay, we'll do foobar. Because I think whenever I was working on this with Claude, I think it actually just discovered something that I didn't realize. Let me see. Connect to an MCP server and initialize a session. So what does the session value actually do, though? Because I just thought about something in here. This key right here, is this going to be always the same browser that happens for the MCP client as it comes through? Now, it might not look like it right now, because if I come over to here and I do like a Docker PS, notice how we've got all these browsers that are just kind of hanging out in here? It's because they're jacked up. So let's kill those real quick. Let's see. Let me stop all of these. There we go. I missed one. There we go. Okay, so we cleaned up all these dangling browsers, because what happens is, since the execution of the agent fails, it leaves all these dangling Docker browser containers. So now that we've got that, damn it, I should have left one of them because I wanted to look at something in this whenever it ran. I wanted to check the Docker logs to see, like, hey, did we see a session named browser come up? Because the whole reason why I was doing this is because I thought this all needed to execute inside of like an asynchronous loop, and it looks like it doesn't. One thing we did here is actually we filtered out a bunch of, we added this tool filter here, and then we filtered it so that way these are the only tools that we actually get from the MCP server, because it was a longer list. This was one of the optimizations we put in. Let me take that out real fast. Let me think about this real quick, guys. I actually need to run to the bathroom, so I'll be right back. All right, let's see here. So you get a list of tools to the MCP server and filters it out, or just preloads its own list. It does the first one. So what it does here is, so we load up the session, right? We prepare the session for the MCP server. That's going to be our MCP client right there. And then what we do is we await this till we get the session, right? So our MCP tools, then what we do is we load that from this session. We load up a list of the tools. And then for our actual tool list that we're going to use is we apply a filter list to this. And so this says if tname, which is, let's see, whatever we pass the input to this, if it's in tool filter here, so if the tool.name is in there and we pass in MCP tools to that, then we convert that to a list and that becomes our tools. So we get the entire list as MCP tools, but then we actually come through and we filter it to say if it's not in this, if it's in this list, then we add it to the variable of what we're actually going to use. And that's the one that gets passed down to the agent right here. Yeah. All right, let's see. And because of this right here, actually I take it back, because of this, the load MCP tools, this is the part that's killing me, because I think we didn't even need to do the async execution loop in here. Like originally I had it for working this. I think this is all massively overcomplicated. So a Lambda function here says, hey, I'm going to take in T and I'm going to return something back out of it. And actually this is a bit weird too, because we're applying a filter, right? So here's the filter that's happening. So the filter is actually where this happens. So we apply lambda T, and then what this does is it returns a true or false. So damn it, I wish the iPad was freaking working. So what happens here is we send in the list of tools, right? MCP tools, or this is the list to be filtered. What we do is we pass in this list where it says, hey, if t.name is in tools, then we apply it to it. So MCP tools gets actually passed in as t in the Lambda function. So we apply whatever this filter function is here against this object, against this list. That comes in, we say, by the way, we return true if it's in the tool filter, we return false otherwise. And then with that filter, we turn it back into a list, and now we have our list of tools. Tifu, what's up, man? Hail from Brazil. What's up, dude? So many places I want to come visit, and I love that I get so many folks from all over the world coming in. That makes me really happy. Because honestly, I don't really get outside of Texas very much. Now, granted, Texas is the size of Germany, so it's pretty large. I can easily drive 10 hours and still be inside of Texas. How's the weather in Brazil? Good, I hope. Let's see. It's too hot. It's finally kind of starting to calm down here in Texas. Usually Texas is very hot. I don't think it's as hot as Brazil, though, because I believe you're closer to the equator. Let me go look at that real quick. Actually, you got me curious. No, hold on. Let's go. Let's back out of it. Let's see. Yeah, it's because Texas, right here, you're right there. So yeah, you're much closer. It's probably much hotter down there. Yeah, quite a bit of difference in the distance. I travel to Austin all the time for work, usually flying in and out of DFW. Cool, man. Hey, let me know next time you're in the area because I live in Dallas. So I was trying to go meet up with CM Griffin, who is also another streamer, very cool guy. Unfortunately, due to me forgetting one night, and I felt like a complete butt for that, and then another night having a time zone conversion error, we never got to meet up. However, I found out he lives up not too far from where my home office is, so I can go visit him next time I'm in that area. All right, how do I want to actually do this? So to do, make this an actually useful agent. Yeah, right. If we're going to do this, then I'm going to get a little squirrely with this real quick here. Let's go over to here. I'm going to make a copy of this. Let's see. I'm going to call this agents.old. There we go. Actually, I'm going to rename this even again. No, not F1. Just tear the F1 key out. See if I can rename this. Sorry for the flashbang there. Call this agents working. A lot of temperature inversion. What do you mean by temperature inversion? I'm curious. Because I can assume, but I'm curious. Let's see. All right, so now that we've got a backup copy of agents working, I'm going to open up this one here. And I'm thinking about just completely, basically migrating a lot of the functionality from the browser agent over and reworking this. Yeah, hold on. I'm going to save a working copy of this too. So now I can work on the agents and the browser in here. Because actually, I like the way the browser is kind of set up, because eventually, if you look down here, this is what's happening, right? Our mapping is we'll have some kind of agent name. It's going to need 3 keys to it, a graph, a mapping, which is like, can it be used by which primary agents, and then a description in here. So if you wanted to have another one in here, right? So let's say like we wanted to call this, you know, super agent, right? we could have another agent in here and how this works. So I like this idea. However, I don't necessarily like this part. So there's where we pass in the execute task for the browser agent. Okay. Oh, so you mean like super hot and super cold in the same day? Gotcha. And a city turns into gray soup. Oof. Let's see. So I'm glad we have a copy of our work. Oh, I like what this is doing. However, I don't like how it's doing it. I fully regret having the AI help me with writing this. Because there's only two pieces of code that were AI helped with, and that is this one, which was almost largely completed by the AI agent, and the other one was one that just helped with it, which was the RoboPages integration. The other one, because I scaffolded it in Grok, and then actually I figured out what it was doing and what it was suggesting, and then I wrote it myself. This one I didn't, and now I regret that decision because I'm trying to figure out exactly what the heck it's doing. I'm gonna have to reverse engineer this entire damn thing, aren't I? I think having it split up is going to work just fine. However, it's this graph down here where this create react agent happens. I think that's the kicker. Hey, No IP, what's up, man? I know, right? It literally feels like it's not even like it's reverse engineering. It's like it's engineering in reverse. Like, I realized this sucks. Let's go back to something different. Primeagent said he hates using language models because it turns into a code review and he hates that. I'm feeling it, man. I'm feeling it. It's different if I'm doing a code review for like something I'm trying to break, but trying to review code that was just written by a language model, yeah. I totally get that. That is an excellent sentiment. Let me look at something for the execute task here, because the execute, this is where we create the agent, and the agent's actually kind of working. I think if we come through and we modify the execute task, right? So let's see, where does state agent get called? Okay, right here. So we look at the agent, we start, if it doesn't have an agent, it starts the browser session, that's fine. Our query is going to be our message state messages plus role. And our task content. Which, when we look at how that's being called, that's our browser task right here. We just get that. Okay. So then we do an A invoke for the query, just like that. That's where this is coming from. Look at this. If we change this one line right here, yep, that's where it's coming from. So if we just change this, I think we'll be good. I'm gonna modify this real quick. So then if we come in here, we say query is just going to be equal to the task content, because what happens here, let me put a breakpoint so I remember what we're doing. When we invoke this, what we're doing is we're sending the browser task, right? The browser task is, hey, this is our step task, which is, I believe, a string. Let me just type that real quick. That's going to be a string. And then after this step task comes through, then what we do is we build the build the exploit task context. We tell it what the state is, what the exploit task index is, and then bam, we get all that in there. I'm going to try this. I'm actually going to try just modifying this right here, where what it's going to do is it's going to take the task content, just like that. We're going to change that, just that one line, and see what it does. See the idea? Maybe you could put the existing code into a language model to have it try to make it better. I'm sure I could. However, I'm not sure I want to. I think the browser agent, once I get it working, I'm going to publish it. However, I'm going to also, I think I'm going to rewrite it from scratch. I'm going to map out what it does and why it does it, and then I'm going to rewrite it from scratch. Hold on, it's saying it doesn't like something we did in here. Too many if a length is greater than e length, else few arguments. What? What? Let's see. Let me try this again here. All right, where was it loading this up? Where it so right now it's trying to hot patch in this code. It doesn't like it. Let's see, special agent, agents.py line 4. What? Browser line 19 for some reason. Ah. Well, that's fine, because what we can do is we actually aren't even going to use this, so let's take this out. It didn't like something about the class definition. Okay, I think that was fine. It didn't like something in the theoretical state table that I had working in there. Is this inscription music? Oh no, this music, I think that this particular song is from the Heartbound soundtrack. So if you do exclamation point music, it'll link to it. So part of the soundtrack for the stream is Heartbound, and the other part is from another offensive security company called Red Siege, and they put out a whole bunch of lo-fi tracks that I really like. If you ever watch the YouTube videos, Red Siege lo-fi tracks is what I use as the background music for the YouTube videos. And so, but they're also here on the live stream mix. All right, it looked like it hot loaded in okay, so let's go. Let me see how much time I've got left in here. Let me add an hour to this. Something went wrong. You probably logged me out, because you always freaking log me out. You bastard. Hang on one sec. Let me pop into OPSEC mode and log back in. Because for some reason, TryHackMe always loves to log me out right in the middle of the freaking stream. There we go. Now it's back. All right. Add an hour to this. Oh, dude, yes. I love the Max Headroom background. I keep daydreaming about if I ever get the chance, which I don't know if I'm ever going to like build a new house, then I'll have a little office and studio room in there. But currently it is very much in the daydreaming stage. Let's see. Okay, so that's working. Let's hop back over here. Let's go run the exploitation agent again. Submit. Let's see what happens when it hits the special agent browser. I'm out of tea. Bummer. I'm out of tea and I'm out of Jocko. This is atrocious. Alright, we hit some kind of massive issue with the special agent node here. So what was that issue? Probably didn't like the code change we just did. Oh, expected a dictionary got navigate from upload, yada yada. Okay. So let's go double check something real quick. So that was down here. Oh, because it's expecting this right here. So I'm going to copy this, drop it right here, take that out. And what we're going to do is we're going to take out this message history portion right here. And all we're going to do is we're going to send it. So this sends our message history messages to this, and then actually, as I think about this, we've got two options here. One option is we can back this out. We can leave this just like it is and let this browser agent just completely manage its own state and actually take out this portion here where we build the execution context, right? Let's look at something real quick. So when we ran the exploit agent, let's see. Actually, we'll go back to Stinger where it was running at the beginning of the stream. Let's come back here. And let's go see, like, what did it look like once we got down to here? We're going to look at the entire input, which is going to be a little chunky, but right here. So this is where we make the language model call. So click right here. Our input is we have a whole bunch of information, which is we tell it what we're going to do. Then we have previous exploit steps, and we have all of this stuff. So if we come back here, let's see, then we have an AI message saying, I'll help with that. We make a tool call. We got an AI message response saying, it looked like it worked. How do you want to proceed? We proceed with it. We also have all of our additional information for the exploit step. And then we tell it, hey, navigate to the panel. It navigates to the panel. We get a tool call back. Looks like it's successful. So actually, it looks like we might be able to achieve what we want by taking out all of this, because all the information is being duplicated because the agent is managing its own history, its own context. So let's try that instead. Let's leave. So for browser, let's leave this as is, right? I'm going to leave this just like here. But however, we come to agents, what we're going to do is we're not going to include this part here. So I'm going to put a note here. This is the original. Let's come right here. And what I'm going to do is I'm going to drop this in here. Take this out. We'll call this the modified version. Take this. And then what we're going to do is we're just going to do the step task right here. That's it. In fact, I'm going to take all of this out just like so. Take you out. Just like that. So we're not going to try and provide it context to what's happened, because this agent already has its own kind of conversational context. It's meant to be a persistent browser, keep a history of what's happened in the browser. Let's see. All right, it looks like that loaded up just fine, so now let's go try running it again. New thread. Execute. Come on, big money. Now, I expect it to still fail, but I expect it to fail at a different part, which is, can it get to, because it needs to validate that it can actually reach it can get code execution from the web shell, right? So once it can reach it, we might have to go modify that a bit. And then to do that, we might actually have to go reload robo pages. All right, it's stepping through. Let's see. All right, we're calling the special agent again. Come on, big money. Worst case scenario, what I might need to do is go see if there's a way I can adjust the rate limiting on Claude on the settings side. But I didn't want anybody who was testing this to try and have to do that. All right, let me see what it's doing here, because I think it might have gotten stuck in a loop. Come on, load up. Hydrate. Hydrate already. I think I broke it. I think I killed it. Oh no, it looks like it probably did error out here somewhere. Yeah, we definitely hit some kind of an issue because we hit the graph recursion limit. So let's see what happened. It gets the web shell. It navigates to the panel. Looks like it got the panel correctly. That's fine. And then what does it do after? Wait, what happened here? So we hit the panel, right? So we hit browser navigate. And what does the revisor say? Revisor says it was validated. Everything looked good. So then if we go to the step processor, what's our step here? We need to upload the PHP shell. That's fine. We call the special agent node browser. We call it here. We have all of our message history because it's being handled by this. It doesn't know about the PHP web shell. And then it tried to do a Python exec to make a web shell. No. All right, hold on. Let's see where that failed real quick, because what happened here is, because we took that additional context out, what happened here is it didn't know where the web shell was. It didn't know the path to it. So where does the revisor actually say with this? Hey, Alexander, what's up, man? Thanks for coming online. Welcome in. All right, let's see. So for some reason here it says, failed, we're going to create a new web shell, which is not true. It's not true. You already have the web shell. Hang on. Let me look at the output that it's got here. Okay, so the revisor doesn't have access to the previous task information either. It's looking at the task in isolation. All right. How are we going to do this? How are we going to do this? Hey people, I'm purely falling for the tags on the stream. That's fine, man. How you doing? Hope you're having a fantastic Saturday, everybody. This is annoying. Don't get me wrong, but it's good because we're figuring out where the issues are kind of coming in here. So what's happening is the language model is losing context as it progresses through the system. And the exploit step revisor is losing that context as well, right? It's forgetting what has happened. I think we can actually approach this from a different direction. And that is, what we did is we took out all of the information here, right? And the reason why this is getting chunky because we're taking all of the information back from this agent and getting here. So I think instead what we're going to do is we're going to back out this change right here. Let's back this sucker up. We're going to use this. However, what we're going to do is we're going to change what gets returned from the output. Rather than returning the result, let me look at something real fast here, because what I'm thinking is maybe we just take the last message out of this. That one didn't work here. Let me go back to where Stinger was real fast. Let me scroll down to the exploitation agent. I'm curious, what certs did you start working on when you were transitioning from IT to cyber? So my certification path was a little weird because I actually took the OSCP in 2010, 2011, somewhere in there. Before Kali was a thing, I was taking it when it was still pen testing with Backtrack. And I took it, I studied it really hard. However, I never felt fully prepared for the exam because I was also taking it while I was in school. And I was taking trigonometry, and that was probably, funny enough, one of the hardest math courses I personally had ever taken just because I wasn't so prepared for it. So I had to study very hard. I had a very spectacular F in that class, but I nailed the final exam, so I finished the course with a B. So I was very happy about that. It's a triangle. Yeah, it is a triangle, Noipi. But I had gone through the OSCP a long time ago, but I didn't actually get my first certification until 2000. Actually, I tell you what, I got my first certification when I was starting in IT courses in 2009 when I got my first Cisco certification. So I had those, but I didn't take any special certifications to kind of switch from like IT and networking over to offensive security. I just had the information there. So I did eventually in 2019 go finish my OSCP because I just wanted to get it done. I wanted to check it off the list, right? So I did go finish that. And then after that, I took the RTO from 0 Point Security, the Red Team Operator course. And I think I even have a link to it here. There it is. So I took that one, and then after that, I haven't taken any. I might take a couple more just for the fun of it on cloud security. I'm going to take the courses. I might go take the exam too, just for funsies. Let's see. All right, I want to look at something real quick. So here is where we call the first instance of the browser agent, right? So we get a tool call, we have a language model call, tool call, language model call. I want to look at the output from this. Would this output be enough? If we wanted to, what we could do is we could send this, we could actually double this up. We could, because I don't want to get all three of these messages in here, right? And there might be multiple messages in here. This one, this example said, hey, I received a timeout when trying to browse to it. That's fine. I'm trying to decide if I just grab this last message, would this work? Well, actually, we might be able to trick this just a wee bit. Because what I want is, I want something that's concise, something that doesn't bloat the context and cause us to keep hitting this rate limiting issue. So I'm trying to think of different ways we can cut the context down before I go rewrite the entire browser agent. Which I probably just need to freaking suck it up and go do it. Especially now that I see kind of what the browser agent is doing. let me think how I want to approach this. We could also include an instruction. So up here in our human instruction, right, we say this is what we want to do. Here's our previous steps taken. We could include another instruction here that says, basically, here's your task when the task is completed. We could go prompt this a bit. Here's your task, or actually we could insert a system prompt. Actually, let me see. LangGraph create React agent system prompt. I think this might be it. Let's see. Let's see. I'm gonna go with Jiro. Jiro, what's up, man? Thanks for coming online. Welcome in. I hope you're having an absolutely stupendous Saturday. It is a stupendous Saturday. Had a good day today. I spent a couple of hours with my father-in-law working on the ATVs so the kids could go riding tomorrow. Unfortunately, I've got stuff I need to take care of for my mother, so I'm not going to get to go riding with them, but they're going to have a good time. Hey, Space, what's up, dude? Space! Let's see. So where can I define the system prompt? Let's see. System message. Here we go. Excellent. So we define this is our agent state. We define the system message. When we create this, what we do is our prompt is going to be prompt. Oh, is that what I need to do? Hold on. I don't know if I like that. That's adding quite a bit. Oh, this is a return thing. Okay. That's why. This is a runtime schema. I think there's a simpler way to do that. If we come back over to the browser, and if we go to where we actually instantiate the React agent, where is that? Where did I put that? Oh, I need to take this out. This is trash right here. Get rid of that. Don't want to just leave that floating around. Here's our tools. Here's our create React agent. There we go. So if we look at the doc string for this, see if I can dig through it here. Where's our prompt? Prompt. We can have a pre-bottle hook, response format, prompt. Here we go. System message or string. Okay. I think that's what we want to do in here. So now why is this model set here? This does not make sense. I just realized what we want to do is we want to pass in the language model to this. Dude, is that why? I think I just realized why the rate limiter, because we had actually put in an error catch for rate limiting and it wasn't catching, and I couldn't figure out why. I think it's because the language model is not being passed over to here. I just realized that. What should happen is there's a config file we can import over to this. It should be available to all the browser agents where they can actually do this. Do we need that model string though? Let me double check something real quick here. I don't necessarily want to pass in the model though. Let me see if I can find the actual documentation for it real quick. Okay. So yeah, we could pass in actually an LLM instead of a model to use in here. This is part of the issue, I believe. So let's go fix that. Let's do our LLM is going to equal from our config. Did we import the, surely we imported the config. We didn't import the config. No way. Let me bring this over real quick. Yeah, so this should just be configuration LLM. Yeah. let's do that. So let's do from, I think it's utils.config. Import. Yeah, we'll just import configuration there. And then now what we'll do is on our create React agent, instead of passing that in, what we're going to do is we're going to pass in configuration, and we'll have it pull out LLM. There we go. And we'll drop a little comma right there. Okay. There we go. So I don't want to do this as positional arguments in here. Okay, so now we should be using the proper LLM, so it should help with... It's not going to fix the recursion issue. The recursion issue is because it lost context. It didn't know what the hell to do. Think of it like you have to navigate by what you've done in the past, and it didn't have the past info, right? So we've got that now, and I believe what we can do is we can just put in a prompt. So the prompt is... You are a, let's see, browser agent, or we're going to call you browser agent. You are browser agent. And handle controlling a Chromium web browser. There we go. We're gonna drop this in here, and then we're gonna say, let's see. So you are a browser agent. You handle controlling a Chromium web browser. Let's see. Given a task. Let's see. Let me actually fix this up just a wee bit. Task complete. That may take several steps. Let's see. When the task is completed, summarize. Yeah, we're going to say summarize the actions. Yeah, say that. Summarize. I will say, and the state of the browser. We'll try that. When the task is completed, summarize the actions and the state of the browser. Let's try that. Let's see if we can kind of hack this together. Actually, hold on. I need to double check, make sure it hot loaded incorrectly. It didn't like that. Oh no, we can't import the configuration because it's a circular reference? No way. Dang it. Alright, that's a bummer. I think we ran into this issue before, too. Hold on, how are we getting a circular import? Because LangChain, LangGraph, pre-built, create React agent, utils config. Take some of this stuff out. None of these imports, though, are importing configuration, though. Agents might be having this problem because I believe agents does import the configuration. No. It doesn't import that either. We import context helpers, state, and tasking. So where's the circular import come in? Not sure. We're gonna have to debug this, aren't we? Let's see. Let's see. So enum agent, we import the enum graph, which imports configuration. Oh, because configuration imports special agent loader. Oof. Okay. That's why. It makes a circular import because configuration imports the special agents as they basically get loaded at runtime, and then this is going to try and load the configuration for the LLM. Crap. All right, I got to run to the bathroom real quick and get some water. So let me knock that out real fast, and then we'll figure out how we can unscrew this pooch. That's what we're gonna have to do. So I'll be right back, guys. Hey guys, give me a couple minutes. I gotta go contain Honey Badger. He's trying to escape. I'll be right back. Alright, I'm back. I wasn't pooping, Cypher. Funny enough, it was Honey Badger. I went to go check on stuff, and I could see the light on in his bathroom. And sure enough, he was in there just having a field day. So, Honey Badger, for anybody who doesn't know, that's my 3-year-old son. So, I saw that and I was like, okay, Honey Badger containment protocols. Initialize. Alright, let's see here. So, the problem here is all the special agents get brought over to the config file, and they come over from here. So, we got two options. We can either split special agents out of the configuration, or we could... Now, actually, we can't even bring config in here. I think that's what we're going to have to do is, rather than configuration over here... Oh, I like this idea, but it looks like that's not going to quite work. Let me check something real quick. So if we split this sucker out, here's where we actually call the special agent loader. Alright, I think what instead we'll have to do is we're just going to have to bust this out. And thankfully right now it's only a one file change because it's the exploit agent in here. Because the exploit agent's the only one that accesses the special agent. So if we come over to the exploit agent and we look for our special agents, let's see, where is it? Find, let's search for, let's see, SP. Oh no, it's because I've got the wrong key. It's special agents. This one right here. Okay, so instead what we're going to need to do is just change this. So rather than this coming from special agents, what we're going to do is we're going to duplicate this part right here. I thought this would be a nice way to include this, but nope, we're just going to make that the special agent loader, and then we're going to import that. So we import that guy. We're going to take this out. Nope, not like that. Not like that. So we'll take these out, and then we're going to bust this up. Why did I do that? Mantrue, what's up, dude? Thanks for coming online. Welcome in. All right, we need to take that out, and then we need to bust that out right there. There we go. Let's see. Okay, so we're going to take all this out. Good. Okay, so now what'll happen is the exploit agent will load the special agents directly. That's fine. It's just one function call. I thought this would just kind of make it handy. No problem. We'll get that set up. And then now our agent should be able to import this just fine. Let's see. Should be able to use the LLM now. So let's go check the server and see if everything hot loads correctly. I think it did. I think we're good since we broke that up. Let's go back to the exploit agent. Let's go see. All right, everything looks... oh, that's fine. Go ahead. Make a new thread. Let's see. Everything should be good. Let's just run it again. Now, actually, because what was happening is this LLM object here is what they're all calling, right? So LLM is configured here. That's our chat open AI, right? Let's see. I take it back. It's this one right here. Yeah, it's our Claude model right here. And we have our model, our temp. Everything's good here. However, where did I put that? Where's the... Let me look at the language model helpers real quick. Where's our utils? Oh, wait, that's right. Because in the LLM helper, that's actually where we invoke this, or we pass in the LLM. However, it's not using this function, so this isn't going to fix that issue. It's gonna help. It's a little bit cleaner, but it won't fix. Ah, crap. What do we hit now? All right, what's the new error? Missing a positional argument for the model. Really? Oh, you're killing me. All right, that's fine, because we can actually bring that in from the configuration here. So even though we passed in the LLM, which has the frickin' model in it, rude. All right, let's just throw that in here. Model is going to be... Hang on, let me check something real quick. I believe we can actually just pull that out of the... What properties do we have for a base chat model? Let me see. What, now you need to go outside? You have the worst timing. You and Honey Badger. Hang on, guys. Peaches has to go out. I'll be right back. It's not me this time, Cypher. I'm back. It's freaking Peaches. My puppy. So, Monkey, the whole poop counter thing started as a gag because one of my buddies, and he pops into the stream a lot, his wife is from Thailand, and apparently there is zero social stigma about asking someone if they're going to poop. So, if anybody in his wife's family or him is going to the bathroom, they always ask the question, "Oh, you going poop?" Just don't know why. Zero social stigma around that. So it became a gag that anytime I stepped away, he would type that into the chat. And so I made that command as a joke. And now Cypher just sits there and waits for it. I swear he's got it on a macro where you can just, he's be right back. Bam! He hits it. Yeah, my perfect little angel there, Cypher. Let me look at something real quick. Let's see. Why do I need the question is, why do I need the LLM if I've got a model? That's what I don't get. Maybe it's the version that I'm using here. Hold on. Which version of LangChain do we currently have installed? Let's go check this real quick. All right, what version of LangChain are we running? So we're running 0327, which I think this is, yeah, so this is the correct one. However, we have a prompt that we're going to use. We could potentially also pass it output parser, tool sequence. I don't see model in here though. I think the problem is which one we're importing. Because see this? This one is actually importing it from pre-built. I mean, okay, there's create React agent. Where the heck is the doc string for this thing? I'm starting class next month on the Sans GIAC cert. Nice, dude. I heard it's hard, but it's good and expensive. Okay, I gotta remember which one exactly is the GIAC. Let's see. The Global Information Assurance Certification. Develop and administer premier professional cybersecurity certifications. Let me see. Let me remind myself which one this is. Nope, that's not it. Oh, I thought that was the particular certification. Which cert are you doing there, Noipi? Gotcha. GIAC is the issuing body. Get it. Because Sans has a whole bunch. Let's see. Oh, you're doing 4. Nice, dude. Offensive operations. Let's see what we have here. Let's see. That's incident handler. GTRP, I've heard decent things about. There's also some of their other ones in here. Let me see. Cloud pen tester. Usually, my usual prerequisite if you're going to take a Sans cert is only take it if your company's paying for it, because Sans is crazy expensive. But also, if you've got the money, it is your money to spend. Oh, that's why they're bringing this from LangChain.agents. We're pulling this from LangGraph pre-built. That's the difference. Okay, I gotta figure out where this is. This is from LangGraph create React agent. Yeah, so LangGraph pre-built create React agent, and when they do this, they're passing in the models, tools, prompt. All right, so why does this one need... Okay, simple enough fix. What we'll do is we're going to bring this in from LangChain. Instead of LangGraph pre-built, we're going to bring this in from... Let's see. LangChain dot... I can't... Oh, help if I spelled chain properly. Dot agents. Create React agent. So taking the GFACT, which is security foundations, security essentials, incident handling, and then GPIN. Nice. GPIN is the one I was trying to think of. Yeah. I'm using the full force and power of the GI Bill. Nice. You earned it. You should use it. All right. Let me see if I can take this out now. Expected a base prompt template, instead it got a string. Okay, that's annoying. So there's two. So there's two different create React agents. There's one from LangChain and there's one from LangGraph. All right, let's back this crap up again. So we'll use the one from LangGraph. But now it still wants a model to use whatever we're calling. Let's see. LangGraph, let's do that. Pre-built, create React agent. API reference. Okay, maybe this will take me to the correct one. All right, so it wants a model, it wants tools, prompts, and responses. We can't pass in the LLM? That is lame. Lame, sir. All right, what we'll do then is we will go grab whatever the model is from this, which I think we can grab that from the LangChain base graph. can we not? It looks like we can. We can probably get model here. Let me try something real quick. I'm going to take this. No, I can't take this out because I'm going to break the rest of the code if I do that. Let me see. Where do we import this from? We need to import. Okay, I'm going to do a quick test on this real quick. So let's see. From LangChain, I'm going to import. What was that? Chat Anthropic. Oh, it's like I forgot it. It's from LangChain Anthropic. Chat Anthropic. So we're going to import that. And then once we import that, what we're going to do is we're going to just use this little bit of code right here. Drop that in. And then now if we just look at Claude LLM, if we look at .model, what do we get? Claude 3.7 Sonnet latest. Okay. So we can do that. We can just pull it directly out of whatever the LLM object is. Perfect. So now, what we can do, we can still pass the LLM, but it still wants this. So we'll just do it this way, because you're rude. Actually, I don't think it even takes the LLM in here. Let's see, it'll take a model, it'll take a tool, a prompt, or a response. It does not take an LLM base model in here, I don't think. It can take in a callable with the state schema and a couple other things. We can do a pre-model and a post-model hook. We can also put in a check pointer if we wanted to, but nothing else in there. And it returns a compiled state graph. All right, so that's fine, because what we do is we've already got the configuration for the LLM in here. So we'll drop that in here, and then what we'll do is we'll just get, what was that, model? Dot model. So we do dot model. Bam. There we go. All right, now let's go try this. Even though it can't even take the LLM. Guess I'll just take that out. That's annoying. Save that. Let's go see if it actually loaded up correctly. What the heck is a HackBot? So HackBot is a fun little project I'm doing because I work in my day job as a penetration tester. And because of that, I've seen so many real-world networks I don't really like capture the flag challenges. So I'm making a AI bot to go play the capture the flag challenges for me. There's a bit more to it than that, but that's essentially what we're doing here. And so HackBot's job is to go through and play like Try Hack Me or Hack the Box. And we're doing, it's a very, very early development. I will only work on it on the weekends, but here's what it looks like. Let me collapse this down. So this is the main execution workflow graph. We're doing everything in LangGraph for it. So it comes through it. It should take some user input, kind of initialize that. Stinger, right now it's very dumb. It's just taking like breadcrumbs that we feed it. But eventually Stinger will look at this base information we give it and start formulating a plan for how to hack the system. So it's got 4 primary agents. There's recon, enumeration, an exploit agent, and then there will be a 4th one over here called post-exploitation. We haven't gotten to that one yet. There may be a 5th one over here. I'm not sure. I don't think so. I think post-exploitation is probably just going to be the 4th one. And then eventually we'll loop back around to Stinger, because right now, like I said, Stinger is very dumb. It doesn't even make any language model calls. It's just strict code. And what we're doing at the moment, though, is we're trying to get the exploitation agent stable. It's very, very close to performing a very basic PHP web shell attack. However, there's always some road bumps, and that's what we're hitting a lot of. So, namely, if we come over to the exploit agent here, this is what the exploit agent looks like. Let me bring some of this stuff kind of around. There we go. So this is kind of like the main execution loop. Actually, I can bring this over here. We don't even need that. Is that once we kind of decide what exploit we're going to do, that's what the exploit agent does. It's like, hey, I think this is the exploit that's going to work. We pass it over to the planner. Planner says, okay, here's the steps we need to do. And then it runs through this loop where it can either make tool calls or it can call specialty agents to go execute various tasks to perform the exploit. And it runs through this kind of revising loop. And it has to do this because in this particular example, uploading .php files is not allowed. You have to rename the extension. And it's already done that in one example, which is really cool. But we keep running into issues where it gets lost, it gets sidetracked. So we're just trying to get it stable right now. And so I started this project because I'm actually not very good at coding. I wanted to get better at it. Hacking on code and modifying it, yeah, done that a lot. But building something from scratch, I haven't. Plus, all these agentic systems, they have lots of issues with them. And so by coding this, I'm learning what those issues are because my clients are going to start implementing it. And in fact, in about 2 weeks, I've got a big, giant blog post coming out. I'll link everybody to it up on Discord. And it's going to walk through like kind of what's the current state of language models. It goes through history and then where everything is today and what the security problems are with that. As someone who's dying to who is doing try hack me right now, I think it's a really cool idea. One question though, do you like CTFs and why? So I do and I don't. I like them for helping teach people. I don't do them necessarily for fun. Occasionally, we will go pull one up on the stream. I'll get a wild hair up my booty and I'll be like, hey, let's go do one. The kicker to CTFs is they don't necessarily prepare you for penetration testing, which is what a lot of people use them for. They're kind of like Sudoku for hackers. I do like them because they teach you a certain execution pattern. They teach you a little bit about different technologies and how to think about them and how to go through the reconnaissance and enumeration and exploitation loop. However, they lead you down a path where you always feel like you need to root every system. And so the smallest network I've ever done a penetration testing on was about 30 hosts. That was the very smallest one I've ever done. And that is huge, ginormous, bigly compared to any CTF that you'll find. So it gets you stuck in this role of like, okay, I got to go in, I got to hack every box, I got to root every box. But that's not typically how a penetration test or a red team works. You have an objective you're trying to achieve, and a lot of the stuff in the environment's all just fodder. You don't need it. You do your recon, you do your enumeration, and then you can find out what the targets you need to move through to get to those. I'm allergic to joy. I am not allergic to joy. Don't get me wrong. It is super fun whenever you figure out what the exploit is and whatnot. But at the end of the day, I do this during my day job, right? So then it's like, oh yeah, cool. I'm doing this during the day. And then it was just like working for free in the evenings. That's the reason why I don't personally like bug bounties. I don't have a problem with them. I don't like them. I don't like doing them because it felt like I was working my day job for my salary. And then I'm coming in at night and like hopefully working for tips. That's the way it felt. I was like, nah. So one thing I really like about this project, it is very closely related to what I do for work, but it is just removed enough that it doesn't burn me out working on it. Because my manager actually asked about that. She was concerned that I was going to burn myself out with some of the stuff that I do. I was like, no, this is different. I don't do a lot of coding during my workday unless I'm working on something specifically. I also don't get to really like mess with these agent systems, and I'm working in a CTF. I'm not working in a higher stress environment like working for a client. So, nah, it doesn't bug me at all. I'm already in the blue side of the house right now, only because I don't know what red team is fully about. Only ever heard of pen testing, which is probably like having a skewed mindset on it. Not necessarily. So, now the ads just popped up, so I'll let them run for just a second, then I'll answer people's question here. But there's a big difference between penetration testing and red teaming. I do both. Get ready to start a red team assessment soon. All right, I think we might be able to just run this now. Let me add an hour to this because we're going to run out of time before the stream does. All right. Where is this? There we go. All right, let's run the exploit agent again. All right, it's running. Hopefully we have all of the context in the correct places so it knows what it's doing. Okay, the ads are done. So Peepo, the difference between a penetration test and a red team is largely the tools used and the stealth component. So when you're doing a red team, typically those are unannounced, meaning there are key people in a network or in an organization that understand this is happening so they can de-escalate and put the fire out if something gets detected. But other than that, your SOC, all your incident responders, they don't know what's happening. Your job is to try and go in all sneaky squirrel and achieve some kind of an objective. Now, to flip that on its head, a penetration test is you're going through and you're trying to maybe avoid some systems that are going to block you, but you're not trying to be quiet about it. You're just going in and trying to see what are the different ways you can achieve an objective. That's the big difference between the two. It's that kind of like OPSEC consideration. All right. Where are we going with this? Let's go see. All right, so we get our web shell. We navigate. We take a snapshot. We click. What? We're clicking? We do an upload. What? Okay, that's not good. Stop, just stop. What the heck was going on here? Something rotten is in the state of exploit or browser agent in here. All right, let's go back. Let's start with the planner here. So here's our planner. Planner steps are obtain the web shell, navigate to panel, upload the PHP web shell through the form, access the uploaded web shell from uploads. Okay, great. So we take care of the first task with this Diceco. We get a Diceco artifact. That's good. And when we do this, it validates. So we're set. Step processor then says, okay, our next step is to navigate to the upload form here. Since that involves web browsing, I'll use the browser agent to provide access to a fully functional web browser. Boom. Calls the browser agent. All right. What the heck do we have going on here? All right. We do have our new system prompt in here. So you are browser agent and handle controlling a Chromium web browser. You're given a task to complete that may take several steps. When the task is completed, summarize the actions and state of the browser. So our human says, hey, you're going to navigate to this panel. Previous exploit steps are listed here. Okay. So it says, I'll help you navigate. We hit navigate. What's the response from this? Actually, let's check what the browser navigate came back with. It should be good. Yep, looks like the navigation happened just fine. Oh God, why are you doing this? Now that I can upload, I can see an upload form for the page. Let's take a snapshot to understand the structure. So it takes a snapshot. All right, then what does it say? I can see the upload form with a choose file button and an upload button. So now I'll proceed with uploading the PHP web shell. Wait, who told you to upload a web shell? You're supposed to, but you're not supposed to do it yet. What in the name of Zeus's butthole is happening here? What is going on here? Hold on. Let's see. So first let's click choose button. Okay, we choose button, and then what's it gonna do? So after it clicks the button, Now that the file chooser dialog is open, I'll upload the PHP web shell. Okay, so we browse file upload. We click the upload. Server responded. Hold on, let's go see what this response is from it. How did it analyze this response? I noticed that after uploading, we received PHP não é permitido, which is Portuguese. Portuguese for PHP is not allowed. Okay. So what do we check on the browser, or why are we checking the browser console message? What is this thing doing? So I noticed that after uploading, we got this. Let's check if there's any other information on the page to help us bypass this restriction. So it pulls a console message. Hold on, let me go back. So we can actually see all the descriptions for these. So console message says just returns all console messages. Okay, hadn't seen it do that before. Now, how did it parse this out? Okay, so since the PHP upload is being blocked, we'll need to try a different approach. Common bypass techniques include using a different file extension that might allow, but still execute it as PHP. All right, this is highly unexpected. And I wish the freaking tablet was working so I could diagram this out. What should have happened is it should have done the browse and said, cool, we're done. And then gone to the next thing. How did it figure out that we wanted to upload the web shell? I have no idea what this is doing. All right, let's see. Okay, so hold on. So what does it do now? So is it going to try in... Hold on. So it does a browser click on choose file. And then from this, what do? I don't have the ability to rename the file directly. So let's see if we can bypass the restriction using a PHTML extension, which sometimes excluded as PHP. Okay, so we go to browser navigate. It goes back to panel. And then why does it go back to panel again? Oh, so it's refreshing the page to cancel the first chooser. Okay, so then after it does this, what do? Hey, Oni, what's up, dude? I was just talking about you, actually. Because people are asking why the hell there's a poop tracker on the stream. So thanks for that. Oh, so it's trying to close... It's trying to close the pop-up. It's got a file chooser modal. And so, yeah, thanks, Oni. So it said, let me navigate away first and then go back. So it navigates to the root. Oh, because it navigated. All right, let me double check something. Let me double check something in the Playwright MCP. Let's see. Let me check the list of tools that are exposed, because if we expose, oh, maybe we need to expose a page refresh in here. Where's our tools list? Tools, let's see. We don't have a page refresh? What about is there a reload? Chuck Norris doesn't flush the toilet, he just scares the shit out of it. I do love a good Chuck Norris joke. Here, I sent this one in Discord. Just because I hadn't seen a really good Chuck Norris meme in a long time. This is it. That's how Chuck Norris uses a lightsaber. He just turns it into a club. Oh, too funny. All right, so for some reason, we don't have a refresh button. I don't think we exposed browser press key, did we? So we might need to expose that one too. Let's go. Because in that case, we could tell it, we could add some more information to the browser in here. So let's see. Actually, we did expose browser press key. So when you complete a task, summarize all the information available. And then what we can do is we'll give it another what was the actual what was the actual language that it used? Because you have to remember, all these language models are doing is they're doing things in a vector space. And they're looking at word similarities and relationships. That's what they're doing. So what did it say? We're going to try reloading the page completely. And then after that, I think it tried to navigate away. Look at all this. It was just going absolutely buck wild in here. All right, let's go back. Let's try handling the file chooser and then navigate back. Let's see. Still having an issue with the file chooser dialog. Okay. Let's put in, so we're going to put an additional directive in here. Let's see. Let's see. You can. I'm going to put a note in here. Let's see. File choosers by pressing the escape key. We'll see if that helps it out a little bit. We're going to give it another tiny piece of information here. And then we're going to see if it gets stuck in that loop again, because it was in there for a while. Now, there's one other thing we got to figure out here. I'm going to come to the very bottom, and we're going to just read the entire chat conversation. So we go to the latest language model call. If we come here, so what we told it is, these are the system instructions. You're a browser agent. You handle controlling a Chromium browser. You're going to be given a task to complete that may take several steps. When the task is completed, summarize the actions and the state of the browser. Perfect. Okay. So we come up here. We didn't tell it anything about uploading web shell. We told it the task is to navigate to the upload form. That's it. And we told it what the previous exploit steps were. Just like that. So I'll help you navigate to the upload form and continue with the exploit. No one told you to continue with the exploit. Maybe I should take the word exploit out and just say previous steps. I think that might be the better option to do in here. So let's come back over to agents. Let's see if we can just decouple that a wee bit. All right, where did we actually call that? So here's results, browser task, and then those are exploit task. Let's see, build the exploit task context. Oh, because that actually comes from that function. Previous exploit steps. We do want that. Okay, that's fine, because what we can do is we can massage this. We can massage this a little. We're gonna usfraba this sucker. All right, what we're gonna do is we're gonna say this is the task. And then we're going to close it. So we're going to do the faux HTML in here. We're doing a little bit of prompt engineering. You feel me? All right, we're going to drop that in. And then over here in the browser, we're going to modify his system prompt. So we'll go to the system prompt. We're going to say, you'll be given a task. So we're going to make this faux HTML also. Let's see. When the task is completed, summarize the action and the state of the browser. Yep. I'm going to clean this up just a wee bit. So this should be, we should have a backline right there. And then handling a Chromium web browser. Let's see. I'm going to actually make this here. We're going to call this common. Actually, I think it's fine the way it is. So you can close file choosers by pressing the escape key. Because the actual, what was the browser press key? Yeah, we'll do that by using browser escape to send escape key. What does this one actually take? It takes a string. Name of the key to press or character to generate, such as arrow left or A. Okay. I used to see Chuck Norris at an old job I had in high school. Dude, awesome. That's what Chuck Norris would shop at the Target I worked at. That's awesome. And oh, that's because you were in California, right? Yeah. The more I watch your streams, the more I feel like it's going to, like you're going towards the development route. Nah, I do enjoy this though. It's fun for me doing the problem solving and thinking about this because there are things that I do want to build, and I enjoy this project. I can't say I'd go enjoy like somebody coming in saying, "Hey, go work on your Jira tickets." But I have been enjoying this project because it melds a lot of objectives that I've got together. It also covers a lot of topics I'm very interested in. So in the blog post that's coming out in like 2 weeks, it's actually going to give an example of how agentic design can go awry in there. And it is a contrived example, I fully admit that, but it was contrived that way for a reason. It's meant to show what happens when people just want to throw language models at the wall and see what sticks. I'll be honest, right now, we're just throwing science at the wall. We're going to see what sticks. By the way, do not snort moon dust. It is pure poison. I am deathly ill. And for anybody who got that reference, you get plus 20 cool points. Yeah, you were pretty close to Hollywood when you were in California. Yeah. All right, I think... Let's go see if this works. Let's see. I kind of I'm trying to decide, do I add something in here? It's like, you'll be given a task to complete that may take several steps. Focus only on the task, maybe. Yeah, I'm gonna put one more line in here. Focus on completing only the assigned. Yeah, we'll say assigned task. Our little faux XML in here. Okay, let's save that. We'll make sure it hot loads correctly. There we go. Cool. Let's try running it again. All right, 7,842nd time is a charm. I'm surprised, honestly, I haven't burned through more of my Anthropic credits. I had $100 in Anthropic credit. Using this project, I think I've used $35. People have been saying prompting is dead. Excuse me. You just need some rejiggering of your prompts. Yeah. You gotta prompt it. You gotta prompt. You gotta get your prompts in. Alright, so we're down in the special agent node, which we don't have visibility into. That is the only downside. We'll see it over here in the trace, but as far as LangGraph is concerned, we won't see it, unfortunately. We can kind of see it over here, though. For some reason now, it's just loving that browser snapshot. I don't get it. Let's see. So now we told it, what is its job? Let's go see where it's at over here real quick. So it's still in the special agent execution. Special agent node. Browser snapshot, browser click. Let's see where you're at with this. Okay. Task completed. I have successfully uploaded the PHP web shell using the file upload form. Here's a summary of what happened. The initial attempt to upload a PHP file was rejected with not permitted. Using the .php extension, which is an alternative extension that can still be executed as PHP, but may not be blocked by simple file extension filters. We were successfully able to upload it. Server accepted the file and uploaded to uploads directory. The system provided success message. The server provided a link that points to the uploaded web shell. Hold on, so did we crash out now? Because I'm still expecting a crash out. This is not good if we are still in the special agent node. What the hell? Why are you still running? You should be done. You should be so done. What is the next step it's trying to do? Friendly Creative Seal, thank you for coming online. Welcome in. Welcome to the chaos of trying to understand what the heck is going on here. Okay. Now it's going to try and do the upload again. Guys, cancel. For the love of God, cancel. So now what's happening is we've made the browser agent too freaking good, and the browser agent is sitting here trying to knock out the task beyond the scope of what it's supposed to do. Before, it wasn't helpful enough. Now it's like, I got you, bro. And it's coming in freaking Arnold Schwarzenegger dual M60s and just mowing down the lab. However, then the exploit agent doesn't know how to track this new rogue Jason Bourne agent that it's got. This is nuts. Yeah, Norpy, I still use dial-up. Yep. This whole stream is running on 56K.
What, your mom buy you a pewter for Christmas?
I'll have you know, my mommy loves me and says I'm cool. The scope creep is real with the agents. Amazing and scary all at the same time. I know, right? All right, so now what we need to do is go triage the exploit agent and figure out where did the browser go from super helpful browser agent to full-on freaking Jason Bourne. I hadn't heard this dial-up sound for ages. I know, man. That's why I put it in here, because I'm just nothing but a giant nostalgia berry. Hey, guys. Remember dial-up? All right, where did this thing... Let's figure out where this thing went off the rails. I saw a video where some guy cobbled together a lot of 56K modems and multiplexed them so he could stream YouTube. That's awesome. I know there's some places that still rely on dial-up, and it still works. But I'll be honest, I'm glad not to have dial-up. I have a nice fiber connection to my house. All right, so we get the web shell. That's good. And then we call the special agent browser. Okay, so when we get to the special agent, our input here is get a PHP web shell. So it says, I'm going to navigate to that. Let me do that right away for you. Looks good. It navigates. And then says, okay. So we navigate to panel. We get this back. Then it says, let me take a snapshot of the page to see the full contents. Okay, so then we take a snapshot. Hey, Ranch, what's up, brother? All right, it takes a snapshot, which I think it already had. That wasn't necessarily a problem. But the good news is it did here say, this is what we've got. So if we have to take one extra tool call to get the summarization, I think it's fine. Now, I think it starts going off the rails after this because what happens, what happened was, I think it's going to start getting all the additional context from the rest of the exploit steps as it goes through. And then the browser agent is starting to act on it. And that's when it goes Jason Bourne mode. Did I try the new Hack the Box? No, Wrench, I have not. Are you kidding? We're still doing the most easiest of easy over on TryHackMe, which is RootMe. We'll go for, normally it's about the time I'd wrap up the stream, but we're going to go a little bit longer tonight because I want to analyze this and try to figure out where it's going crazy on me. So I'm going to diagram this. Unfortunately, I can't show it to you because for some reason, my computer is holding on by duct tape and dreams right now. I have to routinely reboot it like 3 times to get it to actually boot up. It's a pain. So let me see what we did here. So we went through and we did the first step, which was we get DiceCo. And then after that, we call the browser agent. And then after the browser agent, which gets a little bit crazy, it returns back. Let's see, the revisor probably should say it was validated, we looked good. So good, it did actually return us the summarization, right? So this was our summarization that came back. It shows kind of where everything is. And if we come back to the next step should be upload the PHP shell. Yep. So then if we pass that to, actually, so from here, what we do is nav to panel. We navigate to the panel page. And then from there, what we do is, this is going to be the exploit agent. Let's see. So then once we get back from the panel page, we then tell it our next thing is we want to upload this artifact right here. Upload this DiceCo web shell PHP up to it. So then when we tell the browser agent to do this, it has all this context, but we're going to walk back a little bit here. So here's the last human message, right? So the human message in this context is what we're sending to it. So we already sent it all this information here. Oh, I think it's taking the messages. I think what we need to do is chop the context down some more. Yes, because what should have happened here? Let me double check something, because I got to remember how I coded this sucker up. Yeah, this is what sweet dreams are made of, monkey. This is exactly what sweet dreams are made of. Let me come back to the special agent node real quick. If I come back up here and I look at our messages key, we've got 64 messages here. Here, let me scroll through all of these. Okay. So here's our messages. All right. Excellent. Okay, so what we have here is we've got all these messages that are coming back. They're being returned. Let's see. They're not coming back as listed from the browser agent, but that's fine. We can fix this later. We see the browser snapshot. Because up here, if I scroll up a bit, you'll see all these other messages usually have what node is executing it. So it's node and then message. So for some reason, it's not... We've lost the ability to like prepend what that was. I'll have to go double check that out. But we can reasonably tell that, hey, by the way, we're down here in the browser stuff. Actually, this is all kinds of funky now that I think about it. Because look at this. All this information should have been up here. It is up here though. Wait, is this being duplicated? What stage is this project? Let's see. So, for right now, I'd say as far as stages, it is probably about, let's see, we have recon, enumeration, exploitation done. We still have the post-exploitation agent. I'd say these were probably, let's say 10% of the project each. So there's 20%. This is probably going to be a good 20% also, so we're about 40% of the way through. The exploitation agent, I'm going to gauge at like another 40%. So this will be another, because the post-exploitation agent is going to be the biggest and baddest and most annoying, because we're going to have to integrate it over to Mythic C2. So we're going to have to build all of the agentic integration over to Mythic. So we're going to come over here. So this is 10, 20, 80. I'm sorry, no, 10, 20, 40, 80 here. So I'd say we're probably only about 40% of the way through, because this is probably going to, the post-exploitation agent is probably going to be about 40% of the effort, judging from these other ones. And then Stinger is just going to be the one that's going to have to intelligently figure out what to do and hand it off to these other ones. So that's probably going to be about 20%. Especially having seen how the language model's kind of operating, I think that's a fair estimate here. So if you wanted to go like strictly by milestones, this would be like 20, 40, 60. Post-X would be another 20. This would be another 20. So we're about 3/5 of the way through. The exploitation agent is so freaking close, man. It's so close. Ugh. All right, let's check in and see what this guy is doing here. Yeah, there's going to be a lot of context handling that we're going to have to swap around. Because what's happening is this guy runs, and it's got basically its own execution context, and it's running in its own state, let's call it. We've injected some information over into that state. But then eventually we have to get information back out of it to Stinger, into the Stinger state, for it to handle all that stuff. So, I'm thinking that's going to be boring, but that's what we're going to have to do tomorrow. So let's take a look at what it's doing here, though. So, the information it was asked is to upload the PHP web shell using the upload form. So what does it do? It clicks. We do a browser file upload, and we click again. And then if we take a look at what is the response, it should say PHP not permitted. Oh, it says, let me take a snapshot to see where we're at. And then it probably is going to say PHP not permitted in here. Yeah, I received an error of what appeared to be Portuguese, which translates to PHP not allowed. So the upload was unsuccessful because the system is specifically blocking PHP files from being uploaded, which is a common security measure. To proceed with this task, we should try another alternate approach, such as change the extension. Okay, so when this happens, we go to the reviser. What does the reviser say? Reviser should say, okay, this failed. We're going to say rename the PHP web shell to a different extension like PHTML. Perfect. So then we call rename file. That works. Let's see. What it does is it takes that upload task, it injects another task before it, and then that becomes the first working task. So they're both in the working state, but this one comes earlier in the list, so it gets hit first. So it's an ordered list in here. And then after that, what's our next step? After we do the rename, we call browser agent. Browser agent comes through, does a click, does a file upload, does a click, and then a snapshot, and then what do we get? From here, we get task completed. I uploaded the PHP web shell to the upload form. Here's a summary of what happened. So initial attempt to upload the PHP file was rejected. Using the PHTML extension, which was an alternate extension, it could be executed. Good. Excellent. Okay. The system provided success, and we can go to uploads, dice code web shell PHTML. Okay. So now, exploit status. Let's go see. Hey, Jorpy, thanks for coming online, man. Welcome in. Okay, so why did it say it failed? Wait a second. So it renamed the file again. It did another upload, and that's where I killed it. That's where I stopped it, because it looked like it was going off the rails here. Why you do this? Why you do this? Okay. We already did a file rename, though. Why did it say that it failed? So if we do if we check the file upload task, let's see. Let's see what the LM says. Let's see. Oh, I'm sorry. Then it clicks the upload button. So we click upload. We take a snapshot. Let's see. All right. So here we got success. It finished. Then for some reason, it always wants to take a snapshot. I think because we inserted that system message that says, hey, you need to summarize the state of the browser. I think that's why it's taking the browser snapshot. But, you know, it's not such a big deal. Let's see. So the initial attempt to upload PHP failed. What was the whole... Hold on. Let me back this up a bit. So the task it was given, we told the agent... let's see. Upload the PHP web shell using the upload form. Bam. It does that. Where's the browser file upload? So it picks dicecowebshell.phtml. That's good. It hits it. Then for some reason, the reviser says that was no good. All right. So I'm going to upload the steps. I'm going to analyze the status of the exploit, upload the PHP web shell based on the output. Looking at the output, I can see that the initial attempt to upload PHP extension failed. After renaming the file to PHTML, which was provided in the previous steps, the upload was successful. Server confirmed that it was successful. A link was provided to the uploaded file. Status failed. Damn you, reviser. All right, so it's working. But for some reason, the reviser keeps thinking it failed. Because the reviser is idiotic. All right, so I do need to wrap it up there, but let's think about what we're going to pick up for next time, because I say never leave off a project where you don't know where to start. So one of the things we're going to need to do is we need to clean up the return output. So we need to clean up the data that gets returned from the browser agent. Oh, it was working so good. Frickin' reviser. All right, so clean up BA's returned data. So we need to clean that up, and then... Yeah, let me think what else. That's the main thing. We'll figure out what else to work with it on that next time. Urgh. It was so close. Because then for some reason it fails and it wants to rename it to .phtml, which we already had. You're killing me, Smalls. You're killing me. All right. Is anybody over on InfoSec streams? They are not. All right. By the way, guys, if you like interesting hacking content, more hacking content than really what I'm doing, this is really more of a development stream with a nice hacking frosting on the top. Because that's what I do as my day job, and I'm having a lot of fun with this project. But there's people in here doing Hack the Box, doing Try Hack Me, doing different CTFs, just studying cybersecurity and offensive security and defensive security. So go check everybody out there. Unfortunately, we got to go find somebody to raid out to. So over on Twitch, if you have a raid suggestion, feel free to shout them out. Let's go see if we can find somebody new to raid out to, though. Let's see. You got some guy building a retro RPG. Let's see. Zed's online too. Let's see. Data engineering on a Google Cloud platform. Interesting. I should start streaming again. I just need to clean up some crap. Dude, why do you think I use the green screen? If the green screen comes down, it's like, it's just there's a desk behind me that's just piled high with tech junk. It's not supposed to be that way. Let's see. Astro Canuck is on. I don't think I've ever rated him. We might go check him out. My desk is not good. Yeah, dude, don't. I'm ashamed of when people see my desk. Let's see. What if we do this? Who else is online? Texas Miller's on. What's he? He's playing. He's just chatting right now. I was gonna see what game he was playing. Quantum Apprentice says he's playing Fallout 2, but I see him messing with code. Oh, he's doing Fallout 2 modding. Yeah, we'll go right over to him. Modding is always a fun time. All right, guys. Unfortunately, that's where I've got to finish it up for tonight. Oh, the browser agent giving me the blue cojones. That's all right. We're getting close. We're going to figure out why the reviser is just losing its damn mind and saying all the tasks failed. We'll get to it. Hey, by the way, guys, over on the Twitch side, if you get in there, what I want you to do is do me a favor, drop some Hack the Planets in there. Once we get in on the raid, it'd be a good time. So we'll pick it up tomorrow night. We're going to go finish kind of tweaking the browser agent. Where I think we need to tone it down from Jason Bourne to like maybe Hawkeye, something in there, and get it cleaned up a bit. And that's it. It's just part of the game. We're fighting the language models. We're fighting the code, but it's a good time. All right. I think that's everything I got for you guys. Oh, wait, I forgot one very important thing. And that is, I love you. Peace.